You guys ready to rock and roll? All right. Did you guys see the keynote this morning? James, Blue Ocean creator, on stage? Did you guys think that that demo was just doomed? Like, he hit that, and I was like, oh my God, I've been there so many times. But it was a really nice recovery, so if you're in here, well done. So my name is James Faulkner. I am a developer evangelist with Red Hat. I focus primarily on our developer tools and frameworks and runtimes. More specifically, JBoss, our JBoss data grid, and our new OpenShift application runtimes, which we'll be talking about today. So before I get started with that stuff, and this thing seems to be working. Yes. So I was here last year at Jenkins World. Red Hat has a long history with Jenkins. We love Jenkins. We use it internally all the time. We have, I don't know how many masters running in our global networks, but it's a lot. We also contribute upstream. So I briefly wanted to, because this is Jenkins World, and you guys made time to come to my talk today, briefly just mention some of the things we have in one slide, and then we'll get on with the microservices and containers. So we essentially have a number of plugins for Jenkins. So we have plugins for JBoss EAP and Wildfly, which is our Java EE app platform. We also have plugins for Kubernetes, plugins for Ansible, and plugins for OpenShift. In particular, OpenShift and Kubernetes provide a synchronization between Jenkins jobs and OpenShift builds so that you can see on the, if you're using OpenShift or Kubernetes, you can see the progress of your jobs. And if you invoke it, if you start a job from Jenkins, it starts the same thing on OpenShift, and they kind of synchronize together. So we have a lot of investment, a lot of interest in Jenkins, and a lot of people behind those plugins that are contributing to Upstream Daily. So just a brief foray. Well, we're not going to talk about any of that today. So what we're going to talk about today is how developers can build microservices in containers. In particular, developers who are using popular frameworks today and are looking for solutions from vendors like Red Hat. But what we have, essentially what we have today is you can use any framework you want as long as it's one of these three. This is where enterprises are building large applications using enterprise frameworks like Java EE or Spring or .NET. And they're building them into monolithic applications that run and provide business continuity and provide business value. So the first thing a company says is, OK, now we want to go to the cloud. Now we want to be, we want to be cool. We want to be the next Netflix, the next Uber. Let's just dump our application as a whole, entire monolith, into a container, dump that onto a VM running on AWS, and we are cloud ready. We're cloud native. We've solved the problem. While that might sound kind of weird, it's actually, in reality, it's actually a good way to go in many cases. The founder of Basecamp, which is an online collaboration tool, they actually made the conscious decision not to use microservices. They instead created what we call a majestic or fast-moving monolith. This is where you're building a monolith, a traditional N-tier architecture monolith. No microservices, no containers, possibly no containers, but you're wrapping it with goodness like automation with Ansible or Chef or Puppet, or you're building CI/CD pipelines with Jenkins, and the ability to move fast is still there without microservices and without containers. So it's not necessarily a silly idea to do that. If you do not want the additional complexity of microservices, that is definitely a viable alternative. But when you're ready to move to microservices, this is where what we're going to talk about today kind of comes into play. So just a brief one-slide review of microservices. Every other word out of our industry's mouth is microservices and containers today. So I'm assuming most of you have been exposed to the concepts behind microservices and how they help businesses. They're essentially small, single-purpose applications that do a single thing and do it really well. They're designed along business boundaries so that you don't have leakage in your data models, but from one side of the business to another. Or they come from refactored SOA applications where you have functional decomposition and you turn each of those functions into a microservice. They're independently deployable and replaceable and independently scalable. That's really, really important. They're portable across different clouds. That's where containers come into play. And more importantly, they're not necessarily running in the same address space or same VM, same Java VM in the case of a Java application. So you can't really make method calls, right? So there's APIs and contracts where these microservices are talking using lightweight protocols like RESTful interfaces over HTTP. Those are what microservices are. In contrast, containers kind of provide that glue. Essentially, containers were born out of a need for resource efficiency so that you can have multiple applications isolated from one another, but sharing the same kernel, the same memory, the same CPU on a single system to get higher density. But Docker, the company, and Docker, the project, really kind of accelerated the adoption of the concept of containers through their really easy-to-use CLIs, their portable packaging format. They really did us all a favor by bringing that to the market because containers had existed for over a decade before Docker even came into play. It essentially provides resource efficiency, but more importantly, a common language between dev and ops, right? Between developers and the people that are running the code that developers are writing, enabling that portability across that kind of wall of confusion between dev and ops. And lastly, it's one of those prerequisites for success with microservices. You can write a microservice without containers, but good luck getting that into production and getting zero downtime deployments and doing rolling upgrades and blue-green deployments and all those things that come into play when you want to really accelerate your business, because that's ultimately why you're going to invest in containers and microservices, not just because you want to write microservices, but you want your business to grow and you want to be able to deploy bits faster into production and move the business faster. So that's exactly why you're going to do microservices. This is what you typically see with a monolith, right? It's a 3-month period where you start on sprint 1, and 3 months later you have a deployment. Now, your mileage may vary. Some people with monoliths can deploy much quicker than that, obviously, but and some people much slower. And in terms of years or decades even for really, really life-critical applications or avionics and aircraft that you can't just push some code and see if it works or not. So the idea behind a fast-moving monolith is to reduce that amount of time. So go from the monolithic 3-month period, or whatever that period is, to 1/13 of that period, or 1/12 of that period using a fast-moving monolith. You're still not doing microservices, but you're gaining the benefits of that advanced deployment characteristics of a fast-moving monolith. And then lastly, the microservices. This is where you can go from 3 months to 1 week to 1 day, or a few tens of minutes. This is where you really start to see the benefit here. And again, the reason why we do this is for business continuity. But microservices aren't the only part of that solution. That's actually the last thing that you're going to do. The first thing you're going to do, as we heard this morning from Sasha, is that you need to have a DevOps culture, right? If your company is not ready to move to DevOps, you have no chance at success with microservices and containers. There's just simply the culture has to be there. The mindset of the people in the company has to be one that they're willing to adopt the additional complexities and trade-offs that microservices bring. That's step 0, is reorganization. That has nothing to do with containers. Really, it's more of a cultural and people problem. Then next is having self-service, on-demand, elastic infrastructure. So the ability for developers in the company, instead of waiting 3 weeks to get a server deployed so they can start developing, they can go to a website, an internal website, click a button, get a VM or get a container, or get some space on a server and start pushing code to it immediately. That is really going to start generating that innovation that you're kind of stilting, or you're kind of muting it if you don't have that. Step 3 then, once you have all these developers kind of pushing and developing lots of code, they want to get them built, you need to have some automation in place to build and deploy those to your production or to your test or to your staging environments. This is where things like Ansible, Puppet, Chef, and even Kubernetes can help bring some of that automation to those developers who are banging out code and need a way to get it to the different environments in your IT infrastructure in a more consistent way. When you start having all this code being pushed and deployed, it kind of turns into a mess again, right? Kind of what we saw in the keynote this morning, where you have tons of teams doing things and no one really knows what's happening. That's where your CI/CD and Jenkins in particular can help kind of organize the way you push code, the way developers push and deploy and test code and get it into production much faster. when you are pushing code to production, although you may have the sharpest and brightest developers in your company, they're gonna make mistakes. There's gonna be bugs. There's gonna be problems. So advanced deployment techniques at that point are employed to do things like canary deployments. So a canary deployment is where you make a one-line change to one microservice and you push it out to production. You don't immediately start routing 100% of the incoming traffic to that new version. You route maybe 10% of the traffic, and you check and see if that 10% is causing any problems, any production, performance issues or failed transactions, things like that. If 10% works, you bump it up to 20%. If 20% works, you keep going, and you kind of have a checkpoint, an advanced checkpoint to make sure that that code that gets pushed to production isn't introducing any additional bugs. Finally, when you have all of that in place, then you can start talking about microservices and talking about breaking up your different services along business boundaries and getting those autonomous teams to start pushing code using all of the infrastructure that you deployed ahead of time. So the point of this slide is if you want to be the next Uber, you got to kind of start at the beginning. And by the time you get to that Uber stage, then you can kind of retire and move on to the next thing and start all over again. So your journey to microservices is not starting with microservices. So to get there, though, specifically for building microservices, I'm going to talk about three different aspects of these microservices and what Red Hat is doing, and where we see our customers going, and some advice for you guys if you're along this journey. If you're just beginning, great. If you're almost done, great. Hopefully, I'll give you some information and things to think about, and some of the things that Red Hat is providing, both in terms of our open source contributions as well as our support offerings. So first, we'll start with your service. So generally, a microservice is your business logic, a runtime that supports it, and then a management layer which kind of manages all of the microservices together. So we're going to start at the top with your service. So in general, the architecture of this microservice that you're trying to get to is taking that monolith on the left where you've got all of your stuff, all of your EJBs and your JavaScript and your Vert.x verticals and your Spring Beans and all of those things that are crammed together, talking to a database, running on an application server, taking that and moving that to a more containerized and modular microservices architecture where you have small runtimes that are supporting your small independently developed microservices. This is not a microservice how to develop and design microservices. There's 3- and 4-day courses you can take on that. For domain-driven design and event storming and things like that. But ultimately, the architecture is going to be this, where you have multiple containers running the different services managed by a container management platform. So briefly, that entails building microservices. And what you get out of that is, as I said, an autonomously developed and deployed microservice split along business boundaries that do one thing, do it well, do it through APIs and contracts. Your teams are building using agile development processes instead of kind of waterfall stuff. You've got all these microservices fully automated from the developer's desktop out to production with a common packaging format and the separation of data from the individual services so that you don't have this massive database that multiple services are hitting and bottlenecking on. Now you have these independently scalable and highly performant microservices. Sounds great, right? So there's bad parts to microservices, and this is typically why you would decide even not to do them. You're essentially punting. You're essentially pushing the complexity and taking it away from the developer and pushing it onto the operations team. Now, instead of developers having to worry about service discovery in their applications, now the operations teams have to wire these microservices together at runtime. The other bad thing is that, as I said, sometimes microservices don't make sense. The magnificent monolith is a good example of that. This is what Basecamp did. This is what a number of our customers are doing, in fact. Although we try to preach the microservices gospel, a lot of times it just simply doesn't make sense because of that additional complexity. Not all organizations have the skill and necessary makeup to make a successful microservices journey. It takes a lot of things, as we saw in a previous slide. And finally, the last bullet is actually really, really important. Data consistency is really hard, and that actually leads us to the ugly part of microservices. Building large-scale distributed systems is really, really hard. If you no longer can do left outer joins on your database, and now you have to go make a RESTful API call to get some data, when it comes back, join it with this other data, well, so many things could have happened during the time that takes. So losing that ability to do transactive kind of operations on databases really puts a burden on a microservices architecture. Minimizing the amount of dependency, hard direct dependencies you have between those microservices is a really, really good thing to do. If you are ultimately bound and require transactions, really a lot of transactions, sometimes microservices simply, they won't work for you. You need to relax some of those restrictions. A lot of people talk about eventual consistency, and there's like a whole range of different consistency patterns that you can employ in microservices. But if you really want to go down that path, you really need to take a hard look at your data. Building distributed data systems is really hard. The things like CAP theorem, that doesn't go away. You still, you can only choose 2 of 3. So those decisions have to be considered when you're designing your microservice architectures. So again, recommendations. Understand those trade-offs, right? Understand your goals. You're not out to build microservices. You're out to build a system that will help people or deliver water to areas that need it, to make money or ship widgets. You're not out just to make microservices. So understand those trade-offs when you go there. Understand also that it's largely a people and cultural problem. A lot of customers I talk to when we talk about microservices and containers, they say, yeah, that looks great, but my manager's never gonna let us just start deploying Docker containers around the company. So a lot of people need to be retrained, if you will, to think about this in terms of how it's going to improve the business. Also, investing in packaging and automation through Docker and through things like Jenkins. I think all of us here are kind of drinking that Kool-Aid already, so no need to beat that. And then lastly, start small, especially if you have an existing application and you're looking to transition to microservices. Start with a small, non-mission critical part of that application and build that using microservices, using some of the frameworks we're about to talk about. And then start that decomposition process slowly, what's called strangling the monolith, where you start taking small chunks of that monolith and implementing them as microservices instead of doing the big bang rewrite approach, which typically is really difficult for someone to sign off on because you're not getting any business benefit until you're complete and done and everything's working properly. Okay, next section, the microservices runtimes, and this is where we at Red Hat have been investing a lot in the last year or so. So just to briefly look at the anatomy of a microservice, you typically have a small microservice written in Java or Node.js, or in JavaScript or .NET, a number of different languages. It's a small, again, does one thing well, containerized. And then around that, you have these new things that you need for a microservices architecture. These are things you didn't have to have before. You didn't need to discover where the catalog service was in your storefront because it was in the exact same VM and it was compiled and linked together at compile time. There's no need for any of that. With microservices, there are a lot of different things that you'll need in order to make them successful and make them talk. Essentially, it comes down to having a distributed system and being able for those components to talk to one another. So some of these things can be provided by the runtime. So for example, messaging, if you're using Vert.x, which is a reactive toolkit for Java and a number of other languages, it actually has a built-in lightweight messaging bus in it. Other things will come from outside, or for example, even with messaging, you can have an external message broker or message queue sitting somewhere outside your microservice. So the point here is that microservices need additional services that you shouldn't necessarily have to deliver or understand or implement as a developer, but you do definitely need these concepts in your application and in your microservice if they're going to be successful. And then wrapped around those kind of microservice services, if you will, is a need for consistency for building, for deploying, for testing, for managing those things. So how do you get code? How do you build it? How do you push it into a container? How do you put it in a registry? How do you deploy it out to a node running on in your server farm or on AWS? If the thing dies, how does it come back, right? These are all things that kind of operational needs of microservices that are kind of wrapped around that. managing the life cycle of those microservices as they make their way from the developer's desktop into production and then ultimately into retirement. So a number of frameworks and choices you have for all of these different new services that you have. We've gone from essentially a choice of 3 or a small handful of frameworks up until about 2014 to like this Cambrian explosion, as KK says, of frameworks and services and things that you'll need as a microservice developer. And there's all kinds of choice depending on whether you're building cloud-native Java microservices, or you're building cloud-native JavaScript, or you're doing reactive, or even if you're doing serverless. I actually created a word cloud. There's a GitHub repository out there which lists all of the most popular microservice frameworks. And as you can imagine, it's 300 or 400 lines long. It lists everything in the world. I had a word cloud, and it filled up the entire screen, and it was completely illegible. So you have a lot of choice here. So what we're hearing as a result of that is that it's too much choice, right? Our customers and the developers that are working there are telling us, hey, Red Hat, we want to do microservices. Why don't you tell us what you want? What do you think we should do? That's not true in all cases, but in a lot of cases, microservices, although we've been talking about it for a number of years, it's still pretty new. I'm guessing 70% of you in this room work at a company where microservices has not really been kind of accepted as the norm. It's very common. You're not alone. We hear this all the time. We want to do microservices, but we don't know how to start. So how do we get there? So what we've done at Red Hat is we've developed a new set of curated application runtimes for microservices running in containers. It's called the Red Hat OpenShift Application Runtimes, or ROR for short. It's basically a curated set of runtimes that we believe provide those services that you will need for building microservices and deploying them into a containerized environment, with or without Jenkins, with or without a number of other tools as well. But just for the pure sake of building applications, building microservices, and getting those services you need, we believe this is the set of things that you will need. So again, what it is, it's 100% open source versions of these popular frameworks, and we'll get into the frameworks in a moment. These are frameworks that you know and love, so I'll just give you the spoiler. It's Spring, Wildfly Swarm, Vert.x, and Node.js at the beginning, and we'll be adding more in the future. These are frameworks that are tested and verified by Red Hat's QE organization. And then for Red Hat components, like, for example, embedded Tomcat through Spring, it will be fully supported, meaning we will fix a bug and we will ship you a patch. Some of the components in these frameworks that we're about to go through are just like that. Others are tested and verified, and it's kind of a best effort as far as support goes. All of this is 100% open source, so you can use this freely, as you can any other Red Hat project that Red Hat makes products from. That's kind of our thing at Red Hat. The way you get these things is via Maven. So if you're a Java developer, and a lot of our customers are Java developers, you use probably Maven or Ant or Gradle or something like that. We have a Maven repository where these artifacts are stored and will be delivered through what we call BOMs, or bills of material. So you'll know you're getting the correct version if you want to use this. We also have a public Docker registry out there, which contains container images for all of the software that Red Hat produces or supports. So you'll find that there. For example, Node.js, if you want to run a Node.js application, we have a container that will do it for you, and it's in our public registry. It's the big difference between the kind of open source or upstream versions of these and the versions that Red Hat are producing for Red Hat OpenShift application runtimes is it has integration with Kubernetes. Kubernetes, if you don't know, is a container orchestration framework. We have OpenShift OpenShift Origin is the open source project which is built on Kubernetes, and then Red Hat provides support on that as well. But it's tightly integrated with Kubernetes, and this is critical for this because this means that you're developing microservices with containers in mind and with container orchestration in mind, so that you as a developer don't have to understand any of that stuff. All of those APIs in Spring, for example, like Spring Configuration or Spring Cloud, will transparently then be using Kubernetes underneath to talk to Kubernetes, the Kubernetes master, and doing things like pulling configuration automatically for you. So you don't have to do that as a developer. It's a big win, and it's what we kind of believe our value add is to, in that case, the Spring ecosystem. And we also provide a getting started experience, which you'll see in a moment, for both local use, meaning you're deploying it to a cluster running on your laptop for a demo, or if you're deploying it out to a production-grade Kubernetes or OpenShift cluster on AWS. We also have the ability to deploy to that as well. Okay, so here's kind of a depiction of what OpenShift application runtimes really is. At the bottom, the red box here are OpenShift services. So these are middleware services that you've used in the past, things like messaging and in-memory data grid, or a Java EE app server even, if you want to use that. Also, services like CI/CD with Jenkins pipelines. By the way, Jenkins pipelines is a first-class known citizen within the OpenShift and Kubernetes universe. So you can easily integrate Jenkins with OpenShift, as you saw earlier. But we consider that as kind of an OpenShift service. Then above those services are the runtimes, and these are what's kind of new. You see the list there. These are curated. These are the ones we believe will serve your microservice needs the best. Depending on the nature of the application you're building, you'll choose one or the other, and we have some guidance on that. For example, if you really like reactive programming, Vert.x is going to be probably your best choice. If you are a Java or Java EE developer and you want to use those skills to build a Java microservice, then you would look at something like MicroProfile with Wildfly Swarm, or even JBoss as your microservice runtime. If you're a Node person, you're definitely going to want to check out Node. If you're building web apps, high-performance web apps, and you don't need additional Java EE kind of features, you'll go with, say, embedded Tomcat through Spring. And then the tested and verified frameworks above are the frameworks that provide additional features and are very, very popular for use with microservices, like Spring Boot, or Netflix has a number of different open source projects that are used for building microservices, like Hystrix for doing circuit breaking, Ribbon for doing client-side load balancing and discovery, and things like that. So these are kind of these curated lists of tested, verified, and supported frameworks that Red Hat is offering. Of course, you can use Spring, right? A lot of our customers use Spring, and you can continue to do so. But we're offering support now for a number of the components within the Spring ecosystem. We're also offering integration, again, with Kubernetes and OpenShift to make your life easier. If you have Spring experience and you're a Spring shop and you're definitely never going to stop using Spring Boot, thumbs up, right? Now we can offer support for you. Okay, so the getting started experience, if you want to get started, we have a number of different runtimes supported here. This is a web page. It's launch.openshift.io. It's essentially the path into the world of OpenShift and building microservices with OpenShift. It provides essentially a wizard, a 5-step wizard or 6-step wizard. You choose the runtime, you type in the project name, you choose the type of getting started example you want to start with, whether it's a simple RESTful CRUD app, or maybe you want to create an app that has a health check in it, or configuration, externalized configuration. You click the review button, you click the go button, and you'll either download a zip file, which has the project already pre-created for you, and you can just build it using Maven or Gradle, or you can deploy it out to your Kubernetes cluster. You can point it at your OpenShift Online account, which is essentially your own personal account running a Kubernetes cluster underneath, and it'll deploy it directly to that, and you can really get started quickly building these microservices in a containerized environment and managed with Kubernetes. So I want to go through briefly kind of what these frameworks are and how we support them. So for the first one is Vert.x. So Vert.x is a reactive microservices framework for Java and a number of other languages. If you're into reactive programming and you believe in the reactive manifesto, Vert.x is really built for not just reactive programming, but it's built for high performance. It's non-blocking, so every time a request comes in, a thread is spawned. If that thread blocks for whatever reason, it's taken out of the thread pool, and then when the I/O is done, a callback is made, and then the response is given back to the client. In other words, no blocked thread sits there waiting on a response from a database or from some other external third-party service. It also, as I mentioned, has a built-in message bus, which makes it very easy to communicate. If you have a microservice and it's scaled up to 100 nodes or 100 instances split across a number of nodes that don't necessarily run in the same VM, they can now communicate. And the burden on you as a developer is very low. You just simply post a message to essentially treating it like a message queue, a JMS message queue, where you post to a topic with a payload, and then it gets distributed across the network. It supports a number of different languages, so not just Java. As you can see the list down there at the bottom. We at Red Hat are supporting Java, but you're free to use other languages. We just simply believe that the customer demand for our customers at the moment is Java. If you're looking at things like JavaScript, then you'll look at Node.js, which we'll get to in a moment. So Vert.x is kind of a different beast, right? It brings in reactive programming, it brings in lambdas, it brings in streams processing, it brings in a distributed message bus. So it's a bit of a different beast, but it's really, really powerful, and it produces very, very small and lightweight and easy to write microservices. So here's just a brief box diagram of all the things in Vert.x. I'm not going to go through each of the boxes, but the point here is that we have chosen, at Red Hat, we've chosen to support a certain subset of the subsystems within Vert.x that we believe microservice developers are going to want to do. So for example, we don't support console, which is a discovery mechanism. That's generally handled at the infrastructure layer. That's really where it should be handled. We do support things like AMQ and MQTT, which are kind of standardized wire protocols for doing, especially in the IoT world, for integrating different components together. So the point is here, we've chosen a number of subsystems in Vert.x to support. You can still use the other ones. It's not like you can't use them and we've removed them. They're still there. Again, these are upstream versions of Vert.x, but we've chosen to support those that we feel will best serve the needs of microservice developers. Okay, Wildfly Swarm is the next one. So Wildfly Swarm is basically a way to write microservices in Java using your Java EE experience. So if you have Java EE experience, Wildfly Swarm is great because it not only allows you to reuse Java EE experience and write things like servlets and CDI and EJB and all of those things that you find in Java EE, but it only packages up what you need. So in other words, it kind of answers the question, well, Java EE is too fat and slow and we're not going to use it. Now you can package up the two components of Java EE that you need and deploy that as your microservice. So it reduces the footprint, it reduces the memory footprint, disk footprint, and makes it simpler to use. It also creates fat jars. So if you use Spring, you're probably familiar with the concept of fat jars. It's basically a runnable, completely encapsulated application, which contains both the runtime and the application logic packaged into a single thing, which are good and bad. We'll get to some of the trade-offs with fat jars in a moment. It's based on Wildfly. Wildfly is the Java EE upstream project that JBoss is based off of. So all of the Wildfly components are available in Wildfly Swarm. You just simply package them up as you choose the things that you want to package. So it's very easy to use, especially if you are a Java EE developer. So with Wildfly Swarm, there are also things in there for building microservices. So there is health checks and externalized configuration. There's single sign-on support. There's support for topologies so that you can have communication between different instances of your Wildfly Swarm microservices. So there, you can see just a list here of the things that are in Wildfly Swarm that are both supported, which are the bottom sections, what are certified. In other words, we know that they work and we tested them and it's a best effort fix. And then the things that are upstream, you can still, of course, use them, but they're unsupported because we don't feel like those things are typically what a Wildfly Swarm microservice author is going to want. But that can change, right? As customer and community feedback come in, we'll definitely reevaluate each version. Red Hat OpenShift Application Runtimes is tracking these upstream versions. So it's not like we choose one version and that's what we're going to ship. as new versions of the upstream components come out, we'll revise the distribution and the list of certified and supported frameworks in Red Hat OpenShift application runtimes, so we're not kind of fixed in time. Okay, Wildfly Swarm is our implementation of MicroProfile. So briefly, MicroProfile is the answer to, again, Java EE is too fat. While MicroProfile is a set of standards, some of them come from the Java EE world, some of them do not, and it's a set of communities that are working together to build microservices using Java and using those frameworks and APIs that microservice developers need. So for example, release 1.0 of MicroProfile had 3 specs in it, and Wildfly Swarm implement all 3 of those specs. There are 5 or 6 other vendors which provide implementations of of MicroProfile as well, like PyAra Micro, and Hammock has one, and Tommy Tribe also has one. And they're also getting involved in the MicroProfile specification. So release 1.0 came out last year at Java 1. Release 1.1 just came out. We've added health checks and I believe JWT token support, JWT token support is in there as well. And then release 1.2 will come out, sometime after that. So the point here is that you as a developer, as a Java developer, building Java microservices, your choices are not only to build using a fat Java EE implementation like WebLogic or WebSphere. You can also use smaller things using MicroProfile implementations like Wildfly Swarm. Okay, Spring. So Spring, if you haven't heard of it, it started out not as a microservices framework. Spring actually has the longest history of all of the frameworks in our collection. It's kind of an opinionated approach to building applications. It originated when Java EE was younger and fatter. Spring came out as a kind of an alternative to that, kind of providing a very developer-friendly way of building enterprise applications using using the same concepts that Java EE brings in terms of persistence and transactions and things like that. They also have a great getting started experience. There's a Spring Initializer, which is a project to kind of like what you saw earlier with the getting started experience. That's been in Spring for a long time. There are a number of components in the Spring ecosystem. I think there's, I don't know, probably in the order of 50 or 60 or something like that. But by and large, at least from Red Hat's perspective, the most popular is Spring MVC and Spring dependency injection, so the concept of beans and injection points, things like that, and Spring Boot. Those are the kind of the 3 most popular components of Spring that we find. So what are we doing with Spring and Roar? So the Spring and Roar, it's the same Spring. It's just Spring. It's the same one you know and love, except the difference here is now we're testing and verifying it with Red Hat resources and providing additional integrations that we're contributing to the Spring ecosystem. Integrations in terms of Spring Cloud, Spring Data, Spring Cloud, for example, for Kubernetes integration. And those components that Red Hat are producing are completely fully supported. So for example, it's very popular and kind of the default in Spring. If you build a Spring app, you're going to be using Tomcat, embedded Tomcat with the Spring starter for Tomcat. In Roar, we fully support that. We will fix and patch bugs in the Tomcat, embedded Tomcat version and send you a patch. The same is true for a number of other components, especially around the products that Red Hat has, like single sign-on and messaging with our AMQ product. We also, in addition to supporting those Red Hat components, provide that Kubernetes integration, as I mentioned, for for externalized configuration management via Spring Config, and config map is a concept from Kubernetes, and service discovery via Ribbon. So if you use Ribbon for service discovery, it will transparently talk to the Kubernetes cluster and discover the services that you need and give you back IP addresses so that you can do exactly the same thing you did in the past. In other words, no rewrite necessary. If you're using Spring and you want to use it through Roar, no rewrite necessary. There's also developer tooling. So you saw launch.openshift.io. We also have JBoss Forge, which is a code scaffolding tool so that you can quickly and easily create new applications, and create new entities, and create new APIs within your projects using JBoss Forge. And finally, we're also producing a number of starters, Spring starters. These are things that Spring developers use to bring in dependencies transitively so that they don't, all they have to do is remember the name of the starter they want, and then it kind of brings in all of the additional dependencies that you'll need. We have additional plans for additional support for other things in the future. I have a full list. If you're interested, I can give you the list after the talk. The point here is that, again, with Spring, if you're a Spring developer and you want to use a supported Spring from Red Hat and get support for those components, you now have a choice with Roar. And the last one is Node.js. So Node.js has been around for a while too. Everyone kind of knows JavaScript. It's cool again to like JavaScript. It was not cool from from the beginning of the web until Node.js kind of came onto the scene. Everyone knows it. It's got a lot of popular features. It's got a huge ecosystem around NPM. You can see the number, those download numbers are probably about 6 months old now. So we're supporting Node.js 4 with plans to support Node.js 7 in the near future. One thing to add here, Node.js in the first version of Roar is going to be technical preview, meaning it's a kind of best effort support. The main reason here is that Red Hat is building our Node.js committers. We're getting the people that, expertise within the company to build that up. And we're also looking at customers and trying to get some feedback from customers. A lot of our customers are Java shops. And some of them are just JavaScript shops, but and more are coming on board every day, especially with the popularity of Node. So we expect that to move into a fully supported status very soon. Okay, so finally, key differentiators here. Check the time here. Okay, so key differentiators, it's polyglot. We're supporting Java and JavaScript initially. It's best in class. We don't invent everything. We bring in the best. We are unashamed to do that, and that's what Red Hat's been doing for a long time. And it's poly architecture, right? It supports both your existing monoliths and your new cloud-native microservices in one. Speaking of microservices and monoliths, and then in the future, serverless and service mesh. So you might be wondering what the heck those things are. So the evolution of these services, right now, actually the beginning in 2014, when you're writing an app as a developer, you're writing that green box on the far left. You have to do your own load balancing, you have to do your own service registration, you have to do circuit breaking, you're bringing in Hystrix. Over time, those services that you have to worry about as a developer, you really shouldn't have to worry about it. You really shouldn't have to worry about load balancing and circuit breaking. Those are things that can be handled by the infrastructure. So over time, we're seeing these things starting to sediment down into the infrastructure layer, into what we call a service mesh. And earlier this year, Google and some others introduced the Istio. Istio is a robust service mesh for microservices 2.0. This is the next thing after microservices 1.0. It's where all of the stuff you have to worry about in microservices, all the service discovery and load balancing and fault tolerance and circuit breaking, you don't have to worry about that anymore. Literally, you do not have to worry about that anymore. You can just copy and cut and paste, cut all the code out, just remove it. It's handled at a much lower layer in the lower networking layers, as you can see in this hand-drawn thing. You don't have to worry about it. You shouldn't have to worry about it in the application code itself. That's what Istio is. Here's a brief architectural diagram. It's essentially a set of sidecars which act as proxies into your microservices. You don't have to write the circuit breaking logic in your code. The Istio architecture and the service mesh handles it for you. If your microservice isn't responding, then Istio knows that, hey, that circuit's broken. Any calls coming into it should be rerouted elsewhere. So it's a very powerful concept. It's still in its infancy. It's not something that the people are putting into production today, but definitely keep an eye out on that. Okay, I briefly mentioned fat jars, and I know I'm running out of time, so I'm going to fast forward to the fat jar money shot here. So here's a Docker image and the set of layers in that Docker image. You can see your application, if you're writing fat jars, it's at the top layer, and it's over half the size of the entire fat jar. 209 megabytes, that's pretty big. But it's still not huge. But when you multiply that out and you're deploying tens of thousands or millions of times a week in Google's case, that can add up really fast in your AWS bill. So fat jars are great. They're portable. They're easy to understand, but they come with trade-offs. So if you have this issue and you have a large fat jar and you're kind of worried that, hey, every time I rebuild my jar, I'm shipping all of my dependencies out to my networks 1 billion times a day, think about alternatives. So if you want to look at the relative size of a Hello World fat jar, Wildfly Swarm, it weighs in about 45 megabytes, Spring Boot 17, Dropwizard 15, Vert.x 4. These are important to note because one of the things Wildfly Swarm actually can do, you can split those dependencies out and break them out very easily. You can also do this with Spring Boot as well. Dropwizard and Vert.x you can't, but they're still relatively small. But if you're building microservices with Spring Boot or Wildfly Swarm, you can break the dependencies out, put them in a separate Docker layer so that when you change a line in your business logic code, you're not pushing out all those dependencies again. Very, very, very powerful. The concept is creating what we call a thin or skinny application. A fat jar is all of this, right? You have the app runtime, you have the app's dependencies, and the app itself. That's a fat jar. If you split out the dependencies, you can either create a skinny or a thin jar, depending on how creative you want to get with that. The point being here is that there are options for you if you are a fat jar addict and you are experiencing pain because of that. Okay, so we'll skip to the last bit about Kubernetes and OpenShift. So running applications, running microservices, and building them is pretty easy with Docker, right? Docker build, that's your app. Docker run, your app is up and running, your microservice is up and running. Typically, your microservices architectures are going to have tens or hundreds of microservices. So imagine doing that, 100 million times for each of the components, each of the microservices, right? It gets really, really complex really fast. If you want to link them together, it gets even more complex. So Docker is not, the Docker container image is not all you need. You need something that's going to orchestrate those container images and deploy them out. So you need to be able to schedule them. You need to if you have data sovereignty issues and you have to deploy to a certain country at a certain time for a certain type of workload, you need to know when they come up and go down and so that you can replace them if they die. You need to have persistence and storage for them, a number of other things. And so this is where Kubernetes comes into play. Kubernetes will allow you to take those containers and deploy them out wherever you want, whenever you want, in whatever combination is required by your application. It also provides persistence through storage plugins and a number of other features for the infrastructure layer of your microservice APIs. Kubernetes, that's one of a few choices. We believe Red Hat has put all of its wood behind that Kubernetes arrow. You may have heard of the announcement earlier this week from VMware. Pivotal and AWS or Google are joining forces to create a Kubernetes service on Pivotal Cloud Foundry. So a number of big companies are getting behind Kubernetes, and we have been there for 3 years, almost 4 years. And we believe that is kind of the de facto standard for container orchestration moving forward. Okay, but even with Kubernetes, there's more, right? If you have multi-tenancy, you want to have 2 developers on the same system that can't talk to each other's. You need to do something about that. So I'm running out of time, so I'm going to kind of fast forward. The point here is that OpenShift provides that kind of last mile glue for your microservices. So definitely look into OpenShift, especially if you're looking at Red Hat OpenShift application runtimes. You'll need that. We have demos in the booth if you're interested to come by and find out more about this stuff. There's a whole lot of stuff about OpenShift that I kind of am glossing over. My point here at this talk is that microservices and containers, number one, they go hand in hand. You really can't have success with microservices without containers, without a lot of additional work. So it behooves you to really evaluate whether you can live without them. I'll skip that one. So yeah, here's the last kind of sales pitch with Red Hat. We provide all of those services. We provide all of the frameworks that you need, fully supported. And we provide the expertise if you need consulting and things like that. So I thank you for your time today. If you have any questions, I'll be around, and we are at the booth too, as well. So thanks for sticking around.